What I want to talk about next are the concepts of batching and attachment. Those are two very, very, very important concepts in simulation. They give you flexibility for capturing a lot of complexities in the models, and you're going to use that a lot in future models and for sure in the exam, okay? So these two concepts are batching and attachment. What is batching? When we have a scenario where so far the entities that went through the process in our models went through the process one by one, right? We process the entities one by one in each location. However, sometimes we may have some locations in which the processing of entities may be done in a group of entities. For example, we may have an oven in a process, and let's say the time that the parts spend in oven is long and that the operation time in oven is expensive. It doesn't make sense to just process one part at a time. So, but we can group the entities that come and then maybe process 10 of them together, for example. So that's what we call, if you want to capture such a thing in the model, that's what we call as batching, okay? So in the batching, then we are processing similar entities at the same time and location, okay? So these are similar entities that come to a location, and then we have to wait till we have 5 of them or 10 of them or 20 of them, whatever number it is. And then we process that 10 or 20 together, and then they go through the rest of the process one by one, okay? So that's batching. However, so they come together, these similar entities come together, they get processed in that location. That's batching. When similar entities come to a location one by one and then they get processed together at that location, that's what we call batching. Now I have temporary batching and I have permanent batching. Temporary batching is the one that after they're done processing in that location, then they go through the rest of the process one by one. For example, in the oven example, the entities come through the process one by one. They get to the oven. At oven, we wait till we have 10 of them. We process 10 of them together. After they're done processing at oven, again, they go through the rest of the process one by one. That's temporary batching. We group them, we put them in a batch for temporarily. And then they go through the rest of the process one by one as well after the processing time in oven is done. However, in permanent batching, they come through the process one by one. They get to a location when we are going to process similar entities together. And after that, they stay together for the rest of the process. That's what we call as permanent batching. Again, similar entities come together. That's why it's called batching. However, after that operation, when a group of entities are processed together, they stay together for the rest of the process. And that's what I call as permanent batching. When we put them in a batch, it's permanently for the rest of the process. And on the other hand, I'll have the concept of attachment. Attachment is the scenarios when different entities come together to get processed at the same location. A good example is an assembly line. On a machine, on a location, I may have entity A and entity B, two different entities coming together, and I process them together. I perform some operations, and then that's basically attachment, because two different entities come together to get processed on that location. One good example would be putting for example, a product like a TV, for example, in a box. So I can consider TV as one entity, and then box as another entity. They come together to one location where the boxing happens. I put this entity into another entity. That's two different entities come together and they get processed. Okay, so that's attachment. And similar to the batching, I have temporary attachment, permanent attachment. If I put these different entities together and they stay together for the rest of the process, I call it permanent attachment. In the boxing example that I told you, we put the TV in a box and it stays at the box TV for the rest of the process. That's permanent attachment. But we may also have temporary attachment where, for example, I may have a pallet in my system and a product that is ready. I may put the product as one entity on top of a pallet, which is my other entity. They go to the shipping department. Over there, I remove the product from the pallet. I send the product out and the pallet goes back to bring another entity, right? So that's the scenario where I can consider it as temporary attachment. Pallet and product, I can consider them as two entities, two separate entities, two different entities. They come together. Pallet carries the product to the end. At the end, the product is sent out, and then the pallet stays in the system or goes somewhere. So they come together, they stay together for some time. At the end, they get separated again. So that's temporary attachment. Okay, so we in this session and in the next session, we are going to learn how to implement or how to do any one of these four techniques in ProModel, and they are very important as you can see, they can help you to capture a lot of complexities. So what I want to do now in the first part is temporary batching. So we are going to learn how to do that. Temporary batching. Similar entities come together, they get processed together, but it's temporarily. After processing, they go through the rest of the process one by one, not as a batch. What I want you guys to do is to first create a new model in the same folder for week 4. Name your model as El Segundo Composites Temporary Batching. You can see the name of my model on the top of the page, right? Please just right now, create a new model in the folder for week 4. Name your model as El Segundo Composites Temporary Batching. Just because in this model, we are going to learn temporary batching. Okay. This is the structure of the model. Raw material is the entity that we are dealing with in this model. Raw materials come to the system, they go to order queue, and from there they go to ply cutting, to the cutting machine, and then they go to the layup, and then they go to oven, then they go to the ship queue, and then they go to ship clerk, right? The process is specified here. The raw materials go from order queue to the cutting machine, to the layup, to the oven, to the ship queue, and then to the ship clerk, okay? Raw materials, which is our entity, arrive at the time, one at a time, every 60 minutes, exponentially distributed. The interarrival time is exponentially distributed. The important part about this process is that in oven, we process 5 raw materials at the same time. So the oven does not process the raw materials one by one. It processes 5 raw materials together at the same time. And then the raw material goes through the rest of the process one by one. Okay. We want to capture this. Now, from the problem statement, can you tell me the process in the oven, obviously. Can you tell me if this process is a batching or attachment?
Batching is an attachment.
Because? Why?
Is it because it's different parts?
Why do you mean? Like, raw material is my only entity. Raw materials come to oven. When I have 5 of them, I process them together. Which part of it is different entities? Yeah, they are different raw materials, but all of them are entities. Remember in the description, I said similar entities, not similar parts, like, you know. Yeah, these are 5 different raw materials. They are different raw materials, but all of them are same entities. Okay. So do you agree that when we get to the oven, raw material, which is our entity, gets here? When we have 5 raw material, all of them are similar and are all of them same entities, get processed together. Can I say these are similar entities processed together?
Yeah.
Okay, so that's the batching. And then is it permanent or temporary?
Permanent because it's shipped out together.
I said that after they are done, they go through the rest of the process one by one.
Oh, then temporary.
Then temporary. If after they're done on the oven, they go through the rest of the process one by one again, then that's temporary batching. Okay, so that's what we are going to capture here. So I want you guys to please very fast create the locations. And for the locations, I want you to consider capacity of infinity for order queue and ship queue. And for the oven, since we are processing 5 entities together, so the capacity of the oven should be at least 5. If you put a capacity less than 5, and then in the code we write that, oh, 5 of them are processed together, you will get an error. So since we process 5 entities in oven together, the capacity of the oven should be at least 5 so that it can hold 5 entities. The rest of the locations would have capacity of 1. So please create the locations really fast. Create the arrivals. And we do the processes together. I have my locations, as we talked about, my entity, raw material, my arrival, raw materials go to order queue 1 at a time from the start of the simulation for as long as I run the simulation. Inter-arrival time is 60 minutes exponentially distributed. And then processing. Okay. My entity, raw material, goes from order queue to the cutting machine. And then from cutting machine, I go to layup. Right? From the cutting machine, I go to layup. The processing time at the cutting machine is uniformly distributed, average 30 minutes, and half width of 5. What is the other way to give you this information?
Between 25 and 35 minutes.
So the random variable has uniform distribution and it varies between 25 to 35 minutes. Then you have to be able to write it this way. Okay. Make sure you guys are comfortable with that. Raw material. So they ended up at layup. Now they are in the next line, the third line, they are already at layup. And from there, they go to oven. Okay. The processing time at layup is uniformly distributed with average 40 and half width 10. That means the processing time varies between 30 to 50, uniformly distributed. Next, raw materials. That's our entity. Where are we right now?
The oven.
We are at oven. So now at oven, I need to write down the code such that I tell the simulation, I'm going to process 5 entities together. And these are similar entities, all of them are raw materials. And so this is batching. And I know that after this, they go through the rest of the process one by one. So that's going to be temporary batching. So I need to write the corresponding code so that simulation knows what's going to happen in oven, okay? So I'm going to write it here on the operation window. The keyword is group. Group 5 of them are processed together as. So here, basically, I'm going to group them 5 and I'm going to give them a new name. So apparently, as if I'm creating a new entity, which is a group of 5 raw material. So to be able to give them a new name, then let's go to the entities and define a new entity first. Let's go to entities, define a new entity for that, take care of that 5 raw material that come together. I'm going to call it batch. You can call it anything that you want. I'm going to call it batch, this new entity, which is 5 of raw materials together. I'm going to define a new entity. I'm going to call it batch. I'm going to go back to the processes. And here I'm going to say, okay, group 5 as batch. That's the name of the entity that I just created. So group 5, and the blue words are there are keywords. Group 5, group 10, group 20, as many as you want as keyword. The name of the new entity that is basically created as the batch. So we called it as batch, you can call it anything. Okay, so group 5 as batch, perfect. We are not going to put anything on the destination. Leave the destination empty. Everyone, leave the destination empty. Next line. What is the entity in my hand?
Batch.
Batch. I don't have raw material anymore. I grouped them and I created this new entity, which is a batch. Batch. Where am I?
The ship queue.
I haven't done any
The
process.
oven.
Still
Sorry.
nothing.
I'm still at the oven. I just grouped them. I haven't done. You see, I just wrote group 5 as batch. Do you see any wait time? No, I haven't done any processing yet. This new entity, which is batch, is in my hand, 5 of the raw material. I'm still at oven. And here, I'm going to process this new entity, this batch, which has to be processed. So I'm going to say wait. And the processing time here has uniform distribution, average 90, and half fit 10. So the processing time at oven varies between 80 and 110, uniformly distributed. And as you can see, that's what I'm telling, what I was talking about. Usually these processes are the ones that take a lot of time. They're expensive processes. It doesn't make sense, or it's not economical to just process one entity at a time. If it's possible, we try to process multiple entities on those locations at the same time so that the process goes a little faster. Okay.
Professor, where are you getting the uniform distribution data that you're inputting?
I'm just giving those to you. I mean, from the book, that's the answer, but I'm giving them to you.
Oh, okay. Thank you.
Sure. Okay, so I'm processing this batch, and then, as I said, they go through the rest of the process one by one. Then I need to ungroup. Keyboard, again, blue is keyboard. So we group in previous line to create a new entity. We process that new entity, and then we ungroup so that they go through the rest of the process one by one. And pay attention. Again, nothing on the destination side. I see a lot of the students make this mistake. Somehow they put something on the destination side and they get error. No, here for 2 lines, the first line and this is the second line. I do not put anything on the destination side, okay? Next line. What is the entity in my hand now?
Raw materials.
Raw material. I don't have batch anymore. I ungroup that. Raw material, where am I?
The oven.
I'm still at oven. And then I go from oven to ship queue. And then finally, raw material goes from ship queue to ship clerk. Oops. And from ship clerks to exit. And at ship clerk, there's some processing time. I don't know, the guy's boxing, wrapping, doing something. You also have some processing time at ship clerk. Normally distributed, average 15, and standard deviation 5. Okay. Yeah, so all these processing times are the ones that I get from the book. I go to in the same order that model is explaining the techniques. So if you guys need, you can always go back to the book and check and have those as reference. Okay. Okay, let's also calculate work in process here. I need to calculate work in process. Let's go to variable, define a new variable, work in process as integer. Where is the best place to increase that variable?
Sorry, you cut out.
Okay. Okay, so I said let's create a variable that counts work in process for us. Let's go to variables, create a new variable, work in process. And then where is the best place to increase that variable?
The order queue.
Order queue, increase work in process. And where's the right place to decrease that variable? Decrease at?
Ship
After
clerk.
ship
New
clerk.
ship out.
Yeah. Does it matter if I put it before wait or after wait?
Yes.
What is the right order?
After.
Because?
It's still being processed before.
Exactly. I want to finish the processing with the ship clerk. And when the part is really ready to leave the system, then I decrease work in process. Make sure to save, guys, as you proceed. Let's run this for 1,000 hours, guys. And so I have about 193 batch leaving the system. Do you get similar numbers, guys?
I got 201.
That's fine. That's fine. That's just a couple of like 6, 7 up or down. So guys, when you get the numbers, also look at the difference and the scale of the numbers. For example, here, if I get like, I don't know, 10 up or down in the order of 200, that's fine. Here, my raw material exit is 1,000 almost, right? So if I get 100 up or down, I'm fine. I don't need to worry 100, 150, I don't know, up or down, I'm fine. If I had, for example, 30,000 and then over that for this exit of 30,000, I see, oh, some of you get 29,000 or 31,000. I'm fine with that. That's in the order of 30,000, 1,000 up or down, that's fine. In the order of 1,000, maybe 100 up or down is fine. In the order of hundreds, I don't know, 10 up or down is fine. So pay attention to those. So for example, here, if you get 190, I get 993 and then you have 100 up or down, yeah, I would worry for that. Like if you get 93, I would say, okay, something is wrong. But yeah, for sure, your numbers may be a little up or down because our computers may use different random numbers. But see how much up or down you are, given the scale of your output. What do you report for the working process? What is the most meaningful column here?
The average.
Average. On average, there are about 7 parts, 7 raw materials sitting somewhere in the system. After average, what would be the next meaningful thing to report for working process?
The max.
Max. At some point during the process, we have had 20 parts sitting somewhere in the system. Okay. Never report total changes for any variables, never on average time per change for any variable, no matter what. The next thing I want from you is to create a time plot of work in process. When I plot mine, this is how it looks like. The variable in my model changes like this. So as you can see, the working process goes up and down. The vertical axis shows the value of working process over time, how it goes up and down. And as you can see, it's around 6, 7. Most of the time that's where it is. That's the average number that we saw. Most of the time is around this number. However, at some point, we also have observed about 20 around this point of time, around week, close to week 1, and also around this point of time. We have observed about 20 work in process. But most of the times we have stayed around 6 something. And if we look at the variable summary, we see that as well. The average is around 6, 7, and the maximum is around 20. At some point during the simulation, we have reached to 20 as well. Okay.
So for when you're looking at our time plots,
Mhm.
are you mainly looking at like max value, min value, and like the average? You're not looking for it to look exactly the same, right?
So when I look at the time plot, it has different reasons. So usually plotting any variable over time is to just see how that variable is changing over time. That's the main goal. But there are a couple of things you can also extract as well. Okay, most of the time my variable is around 6, 7. Yeah, I can see that. Sometimes it has gone to 20 as well. Sometimes we may draw a time plot for a working process, and we just see this line going up and down, but in an increasing trend. So just going up and down, but increasing. Okay, that shows that over time, the working process variable is increasing. That means there is some bottleneck somewhere in the system because the parts are just piling in the system. Or no, we see that it goes up and down and up and down. Okay, fine. It means that sometimes it's a little take longer for the parts to be done, but sometimes it goes down, so not bad. So this, if I see a behavior like this, that's a reasonable behavior. At some point it has gone up, maybe some process, some random numbers that have been generated suddenly have been large for some of the processes, but most of the time it has stayed around the same number. So I don't expect your graphs to be exactly the same, but I expect similar behavior in if there is no major change in our
Okay.
model.
Okay, thank you.
Sure. In our model, for example, in our location, here we have infinite for the queues. I want to make sure you guys, first of all, make sure your queues are queues. I do not pick any queuing rule for the queues. If you have some queuing rules, like first in, first out, then our numbers may be a little different. The length of the queues, mine is 20 for both, I believe. If the length of the queues are not exactly the same, it may also cause a little bit of change. Yeah, so there are the areas where maybe things in my model are a bit different than yours, but overall, I expect to see similar behavior in your graph and mine.